Guys, what's up? This is Vivek, and I just got this toy DC motor, as you can see, and I have soldered two wires over here at the input for connecting it to this breadboard. I will test this over this battery. So this is a 9-volt battery, and I have just connected a propeller fan on the shaft. Let's see if it works or not. Okay, so this is working. Okay, so this is a DC motor, and what I was thinking is that what happens if we connect this motor with this fan to an AC supply that I will be giving through this transformer. This is a 230 by 12 volt transformer. It's a center tapped transformer, and the output pins are 3, where you can see the first one is a 12 volt, the second or the middle one is 0 volt, and third one is again 12 volt. So this is a 12 volt transformer. Okay, so I'm going to take two of them, a 12 volt and 0 volt, and I'll connect it directly to this DC motor, and we will see how this is gonna behave. Okay, so I have done all the adjustments. You can see that the 3 wires are coming out. I have just left one outside the breadboard, and 2 of this is the 12 volt and this is a 0 volt, and 2 of these have been connected directly to the motor, and this is an AC supply. So let us see what happens if a DC motor is operated on AC supply. So if I just supply this, you can see the vibrations, right? Okay, so while this is happening, the motor vibrates to and fro, and there is no absolute motion due to the AC supply being given to DC motor. And not only this, if I just leave it prolonged like this, the motor windings will burn out. So as you found that the DC motor vibrates very currently on AC supply, so what I'm going to do is just that I will try to make a rectifier so that I will be able to make this AC supply converted to DC and then apply this to the motor. So for that, what I'm going to do is I'm going to use this transistor. This is BC547 transistor. Okay, it looks like this, and you can get it for very cheap. So if you start from the left, so this is emitter, this one is base, and this one is collector. Okay, starting from the left. So this is a BC547, and I'm going to use 2 of these, and these 2 will help me making my bridge rectifier for driving this motor. So let us see how we can do that. So this is the rough schematic of what circuit I'm going to make. This is the transformer, the 230 by 12 volt transformer that I have, and these are the 2 transistors, and as I said, this one is base, this is collector, and this is emitter. So I have this transistor, I have to short the base and collector, and same for the other transistor. And finally we will be shorting the output of the emitter of the 2 transistors, and we will take out one wire out of this short point and another from the center tap from the transformer, and finally when they are going out, we will connect this DC motor. So let us see whether this schematic is going to work or not. In both the transistor, the base and the collector has been shorted in both the transistors, and the emitter goes out, and emitter of both the transistor will be shorted together. So one thing we need to keep in mind, that the base and collector will be shorted together, and the emitter of both the transistor will be shorted together. So I have just ended up connecting the both transistor that we required for the operation, the BC547 transistors, and you can see that the collector and the base has been shorted together, and emitter goes out to this next hole up here, right? And the similar is the case of this transistor, where the base and the collector has been shorted together, and the emitter goes out here, right? You can see. Okay, and emitter of both the transistors have been shorted, and this was according to the schematic diagram that I have drawn. So this is how you have to connect the BC547 transistors for successful operation of the rectifier. Okay, so these are the three leads that are coming out of the secondary of the transformer. This one is 12 volt, the middle one is 0 volt, and the blue one is 12 volt again. So we take one of these 12 volts and we will connect it to the starting point of the base and collector of the two transistors, this one and this one. So we connect it here, okay, and we take another 12 volt and connect it directly to the starting point of base and collector of the second transistor, that is this one, you can see. Okay, so we have just connected it, and this 0 volt you can connect it outside here. So this is how you have to connect the transformer to this transistor. So we have just ended up with our rectifier, and we need to connect our DC motor, and let's see how it works. Okay, so I have just connected the motor, and if you can see that how the connection has been done. So here is one of the lead of the motor that is connected directly to the starting point of the emitters of both the transistors. Another lead goes to this point, which is connected directly to the 0 volt, that is the center tap, according to the schematic diagram. Okay, everything is at place. I have just adjusted the motor correctly so that it doesn't fall, and let us see whether this schematic diagram, the circuit we designed, is working or not. So if I just supply, okay, here we go. So moment ago the same motor, the same fan was just vibrating on AC supply, and now we were able to convert this AC supply suitably to DC for this motor to operate. Here you go. The fan is absolutely rotating instead of vibration, and it's smooth. Now wait a moment. Before operating anything for such a prolonged time, you should actually test if anything is heating. Okay, so for that we will touch each of these individual transistors and check if everything is at normal temperature, the motor is at normal temperature. So in my case it's normal, nothing is hitting. Okay, BC547 are really good transistors. Okay, so we can supply it back.